This video is provided as supplementary material for courses taught at Howard Community College. And this is going to be the first of a series of videos about conditional probability. Conditional probability can be somewhat difficult to understand, so what I want to do is start with a couple of fairly simple, intuitive examples, and then go on to something more difficult. So here's the first example. In a group of 100 students, 40 are taking algebra, 30 are taking biology, and 20 are taking both algebra and biology. If a student chosen at random is taking algebra, what is the probability that he or she is taking biology? Okay, let's visualize this information with a Venn diagram. So I've got 100 students altogether. That's going to be the universe. Within that universe, there are two groups. There's what we'll call Group A for the students who are taking algebra, and there are 40 students in that group. And then there's, overlapping with that, Group B. Group B is the students who are taking biology. There are 30 students in that group. And in that overlapping area are the students who are taking algebra and biology. So there are 20 students there. Now, if the question had only asked you, what's the probability that any student chosen at random is taking biology? In other words, what's the probability of B? That would be a fairly simple answer to get. There are 30 students altogether taking biology. There are 100 students total, so the probability of B is 30 over 100, or 30%. But what the question asks you is this. It says they've already chosen a student at random, and that student is taking algebra. What's the probability that he or she is taking biology? Okay, so this is conditional probability. We're going to write the probability of B given A. Let me explain this notation. The probability, and then in parentheses I've got B and a bar and an A. Well, the B stands for biology, the probability that a student is taking biology, and the bar is given that. In other words, we already know that the student is taking algebra. So we're looking for the probability that a student is taking biology if we already know that the student is taking algebra. The formula is going to be that the probability for B given A is the probability of the intersection of A and B divided by the probability of A. Okay, now let's put some numbers in here and this will begin to make sense. So what is the probability of the intersection of A and B? Well, that intersection is 20 students and there's 100 students altogether. So the probability of 20 students out of 100 is 20 over 100, or I'll just write that as 0.2. The probability of A, since there are 40 students in Group A, 40 students taking algebra, and 100 students altogether, the probability of A is going to be 40 over 100, or 0.4, and that reduces to 1/2, which is the same as 50%. Now notice that 50% is different than the 30% that we got when we didn't worry about whether the student was taking algebra. The 50% makes sense if we look at the Venn diagram. Looking at the Venn diagram, what we see is that of the 40 students who have decided to take algebra, 20 of those, half of those, have also decided to take biology. So if we know a student is taking algebra, we know there's a 50% chance that the student is also taking biology, since half of the algebra students decided to take biology. Okay, so this wasn't totally random. There was the students making up their minds to do this. And it also wasn't something that would be impossible to do without this formula. We could probably look at the diagram and say, oh, it looks like half of the students taking algebra are taking biology, so the probability is 50%. Okay, so this is the first of a couple of intuitive problems I wanted to give you. Here's the second. This one is somewhat the same. In a group of 100 students, 40 were randomly put in a Monday art class. Independent of that event, 30 students were randomly put in a Tuesday botany class. If a student chosen at random is in the art class, what is the probability that he or she is also in the botany class? Okay, so let's do the Venn diagram again. Once again, the universe consists of 100 students. Once again, there are two groups. It's also groups A and B, but now it's art and botany. So in group A, we have 40 students. And in group B, for botany, we have 30 students. And we don't know what the overlap area is. These students were chosen at random. It's not like the students in one group decided they were going, like the students in the art class decided they would also take botany. So we can just figure out what the probability is that a student is taking both. Well, the probability that a student is in art and botany, the probability of the intersection of A and B, is just the probability of A times the probability of B. Okay, because these are basically two independent events. Well, the probability of A is going to be the number of students in the art class, which is 40, over the total number of students, which is 100. So that's 40 over 100. So the probability of A is 40 over 100, or 0.4. The probability of B is going to be 30 for the number of students in the botany class divided by 100, the total number of students. So that's 30 over 100, or 0.3. We multiply those two out. I'll do that down here. We get 0.12, or 12%. Let's leave it at 0.12. So now we know that 12% of the students are in that overlap area. If it's 12% of the students and there's 100 altogether, we can just put a 12 in here because there would be 12 students in that area. Okay, now we want to figure out the probability that a student is in the botany class, the probability of B, given that the student is in the art class. So we've already chosen a student. The student is in the art class. What's the probability that he or she is in botany? Okay, so the formula, once again, is going to be that the probability equals, or the probability of B given A, equals the probability of the intersection of A and B divided by the probability of A, the event which already happened. Okay, well, we'd already figured out that the probability of the intersection of A and B is 0.12. The probability of A is going to be 0.4, since there are 40 students in group A and 100 students altogether. That's 40 over 100, or 0.4. Let's write that as 0.40. And then we can think of that as just 12 over 40. And if we reduce 12 over 40, we get 3 over 10, and that's 30%. Now, this also makes sense and is kind of intuitively obvious. The students who are taking botany were just randomly chosen. So it's not like some subset of the students in the art class decided they were going to be in botany. Any student in this whole group of 100 could be in botany. They were just randomly chosen for that. 30 of the students were put into botany, and that was 30% of the total number of students. So this formula gives us something that, once again, is kind of intuitively obvious. Okay, what I want to do now is go on to another video for something that is not intuitively obvious and is where this whole formula begins to make sense and becomes very useful. So stick around, I'll be back with that one.